Okay, so today we will talk about the machine learning process. So there is a specific step-by-step process that we typically always follow, okay, when building machine learning models. So let's have a look at what this process entails. So this process has three main steps. The first one is called the data pre-processing. Step one is data pre-processing, and here we import the data, we clean the data, and we split the data into training set and test set. We have already covered basic steps of cleaning the raw data in previous sessions. Okay, so data pre-processing is the process of cleaning, organizing, and transforming raw data into a structured format suitable for building and training machine learning models. The data we will be using in upcoming sessions is pre-cleaned. Okay, so we will not be focusing much on data cleaning, right? So that we can focus on other skills related to the machine learning. But keep in mind that in real world situations, cleaning the data is quite an important step. So next step is, okay, we move on to modeling, where we first build the model, then we train the model, and then we make predictions. Okay, so in step two, we build the model, we train the model, and we make predictions. So this is the fun part of the machine learning, and in upcoming sessions you will get a great exposure to several different models, and you will be able to practice, okay, your skills there, right? And finally we move on to the evaluation step. We will calculate some performance metrics and make a verdict about our model, whether it's a good fitting model and if it works well for our data or not, right? And this is a very important step to make sure that the models we build really serve the purpose that they are designed for. So that's the machine learning process. Now let's talk about the importance of splitting the data into a training set and a test set. So let's imagine that you are tasked to predict the sale prices of cars, and that is your dependent variable. Okay, so and your independent variables are, so sale price is dependent variable. We will talk about dependent and independent variables, okay, in more detail, okay, in upcoming sessions. And your independent variables are the mileage of the car and its age, okay, car's age, right? In your data that is actually supplied to you, given to you, okay, you have 20 cars in total. Okay, of course, that's not a lot, but for understanding purpose, for our example, okay, that will be sufficient. So what splitting your data implies is separating a part of your data uh, before you do anything, okay, with the data, and usually that is about 20% of the data. So here we have 20 cars in total, and we are separating out 4 cars, which is 20% of the entire data. So since we have 20 cars data in the given data set, here that is about 4 cars that we are separating out, right? So that means 80% will be our training set, and the separated 20% will be our test set, and we will use our training set to build the model. So in this case we are building a linear regression. Okay, say y hat equals to b0 plus b1 x1 plus b2 x2, so it's a linear regression. And then we will take the cars from the test set. Okay, we have 4 cars in test set, and we will apply our model, okay, to these 4 cars, okay, to the cars in test set. The cars data in the test set haven't been part of the model creation process. The model has no information about these cars, and now we are applying the model, okay, to them, and it is predicting certain prices, right? So we are using this model, and we built this model using this linear regression. So we are now using this model to predict these car prices. Okay, so these are predicted prices, right? So, but the good thing is that because this is something we separated in advance as part of the data that was given to us, okay, we know the actual prices, right? Because we separated out these four cars from the given data. So we have actual prices also. So now we can compare the predicted values which are generated using the model that has never seen these cars before, and we can compare that to the actual values. And from that, we can evaluate our model to check whether is it doing a good job, is it doing not a good job, and do we need to improve our model, right? And that is how we split a training set and a test set. And that is why it is important to do the data splitting into training set and the test set. Okay, we can use, okay, this test set to evaluate our model, right? Next is feature scaling. Now we will talk about feature scaling. Okay, before we dive into the technical aspects of feature scaling, I would like to present with you an image that hopefully will help you remember what feature scaling is applied to, right? So even without knowing anything about feature scaling, remember that feature scaling is always applied to columns. Okay, so feature scaling would be applied to this column, to this column, and to this column. Feature scaling is never applied across columns. So you would never apply feature scaling to data inside a row. Just remember, feature scaling is always applied to columns. Okay, now let's have a look at what feature scaling actually is. So there are multiple types of feature scaling. Okay, multiple techniques, right? So we are going to look at the two main ones, normalization and standardization. So normalization is the process of taking the minimum inside a column, subtracting that minimum from every single value inside that column, and then dividing by the difference between the maximum and the minimum. So basically every single value in a column is adjusted, okay, this way that you will end up with a new column or an adjusted column with values, okay, which are all between 0 and 1. So after applying this normalization, okay, in your column, okay, you will get the adjusted values, and all values will be between 0 and 1. Standardization. So on the other hand, the process is similar, but instead of subtracting the minimum, we subtract the average, and we divide by the standard deviation, right? So standardization transforms data to have a mean of 0 and a standard deviation of 1. Okay, in a normal distributed data set, okay, approximately 99.7% of all the values, okay, lie within the 3 standard deviations of the mean, right? As a result of all the values, okay, the column will be between -3 and 3. Okay, all values of that column will be -3 and 3, and if you have some extreme values or some outliers, okay, then they can end up, okay, outside of these -3 and 3 boundaries. So that's the normalization and standardization, right? Now we will have a look at the normalization. So let's imagine we have a data set where we have two columns, okay, annual income of a person and their age, right? So just simple data with these two columns. Okay, we are only going to have 3 rows, right? So we are going to have a red person, a green person and a blue person. So, and we have red person is making 70,000 a year and their age is 45 years, right? And green person is making 60,000 a year and their age is 44 years. And blue person is making 52,000 a year and their age is 40 years. So now the task at hand is going to be slightly different, okay, to the regressions and classifications. The task at hand is to see which of the two people to the green person is more similar to, okay, just based on this data, right? So can you tell me just by seeing this data, okay, which one of these two people, okay, which one of the two people to the green person is more similar to just based on this salary and age data? Yes. So this case is more relevant for the clustering tasks, okay, or the clustering algorithm. Okay, that we will cover later in this training. But it is just a simple illustrative example that we are going to use here. So we are going to talk about it here to show the importance of the feature scaling. Now let's have a look at this calculation, okay, together. So the difference here is the in the salary here is 10,000 and here it is 8,000, right? And in terms of age, the difference between the green and the red person is 1 year, right? And between the green and the blue person is 4 years, right? So difference here is 4 years. Difference between red and green is 1 year, right? So now what can happen with unscaled features, as we see here, is that the values, the unit values of one column can be so much larger than the unit values of the other that it might overpower. So here 70,000 is overpowering 45, 60,000 is overpowering 44 and 52,000 is overpowering 40, right? So we might make the erroneous conclusion, okay, that okay, we are going to ignore values 1 and 4 as we did. Okay, we ignored 45, 44, 40 and we entirely focused on 70,000, 60,000 and 52,000, right? Because these are such small differences compared to 10,000 and 8,000. So 1 and 4 are very small differences, right? So we are going to focus on these large magnitude numbers, 10,000 and 8,000. And out of them, we will say that the green person is clearly closer to the blue person because the value is 8,000, right? This 8,000, because this difference is lesser than this difference 10,000. Okay, so we can say that this blue is closer to green, correct? And this 8,000 is 2,000 less than the value of the difference between the green and the red person, right? Okay. Now we don't want this or similar things happening in our algorithm. Okay, because our algorithm also, okay, can use 8,000 and 10,000 to make decision, right? We don't want this to happen with our algorithm. Okay, that is why we need to normalize, okay, these values or variables, because we can't compare, okay, these values, right? So we need to normalize these values, normalize these variables, right? So right now we are comparing what? Salaries to years or salaries to age actually. So it is like comparing apples and oranges. Okay, these are known comparable things. Okay, so salary and age cannot be compared, right? So this is like comparing what, apples and oranges, correct? So if age was expressed not in, suppose currently we are actually expressing this age in years, suppose we are expressing this age, okay, not in years but in minutes, then those values would be much higher, or in seconds would be even more higher, right? This is the formula for the normalization. Formula for the normalization is the value in the column minus the minimum value divide by max minus min. Okay, so it will give you what? The normalized value, right? So now we are going to apply it to the columns, okay, one by one. So we are applying it to the income column first. So let's see, do we have income column here? Okay, yes. So this is the normalization formula, and let's apply, okay, our normalization to this data, right? So we are applying it to the, okay, income column first. So this is the first column is the income column, right? 70,000, 60,000, 52,000, right? So after normalization, okay, this is the result. This is the result after normalization. Okay, now you have the formula. Okay, you can apply formula after the session and you will get these values. And our values will look like this: 1, 0.444 and 0. So if you see, now these values are between 1 and 0. Okay, I told you that if you apply normalization on values in a column, that all values will be between 0 and 1. So now these three values are between 0 and 1. Okay, after normalizing, okay, let's apply this to the age column. Okay, this is the age column. Our values will look like this. Okay, so here we end up, okay, after applying normalization we end up here, right? And now we can compare normalized income and age values. So now comparing these values, okay, will be easier, right? So based on this data, okay, which do you think the green person is closest to? Now we have small values, right? Now can you tell me, after based on these values, okay, which person is closest to the green? Because now we can compare normalized income and age values. Okay, all values are on the same scale. So if you see in both the columns, right, and salary and age, all values are between 0 and 1. Okay, so now these values are comparable, right? So based on this data, which do you think the green person is closest to? Okay, well, so I think the answer is obvious, right? So the green person is almost right in the middle, okay, between the blue and the red. If we see this salary data, right, because this is 0.444, right? So this is 1, this is 0, so this green is almost in the middle. Okay, so based on this data, okay, we can say, if we don't have this data, right, if we don't have this data, so based on this data, okay, we can say this difference is small, so we can say it is closer to blue, right? Okay, so it means the difference here is small, right? So based on this salary, we can say this green is closest to blue, right? Now, whereas in the age column, okay, this green person is closest to the red person. If you see, it is more closer to this. Here difference is 0.2. Here difference is 0.8. Am I right? So based on, this is almost in the middle. It is almost in the middle. But based on this, okay, we can say green is closer to red because here the difference is only zero point 0.2. Correct? So it is very clear from this that this is this green is closer to this because this value is in the middle, but this is more closer to this one, right? So that's a quick illustrative example, a very simplistic, okay, but yet illustrative example of feature scaling. So now we can compare these values. Okay, these values are comparable after normalization. Okay, yeah. Okay, so that's all for this session, and thank you for joining. See you in the next session.